In this video, we're going to talk about slopes of polar curves. We could say that y is equal to f of x. In polar, what we could do is we could say that r equals f of theta. And you know that x equals r cosine theta and y equals r sine theta. And using substitution, since r equals f of theta, we could say that x equals f theta cosine theta and y equals f of theta sine theta. And from parametric, we call that dy over dx equals dy over dt over dx dt. In polar, it's very similar. To find dy over dx, that's the same thing as dy over d theta over dx d theta. So in order to find dy over d theta, you need to take the derivative of y. And in order to do that, you have to use a product rule. So it will be f of theta times the derivative of sine theta, which is cosine theta, plus sine theta times the derivative of f of theta. Same thing with finding dx over d theta. Using the product rule, you get negative f theta sine theta plus cosine theta times f prime theta. So putting these two together, you get dy over dx is equal to this expression over here. And let's take a look at an example. It says find the slope of the Rose curve r equals 2 sine 3 theta at the point where theta equals pi over 6, and use it to find the equation of the tangent line. So in order to do this, we need to first find the slope of this curve when theta is equal to pi over 6. And since x equals r cosine theta, you know that using substitution, x will be 2 sine 3 theta cosine theta. And y is r sine theta. So again, using substitution, substituting 2 sine 3 theta instead of r, you get 2 sine 3 theta sine theta. Now taking the derivative of y with respect to theta, you are going to get, using the product rule, you are going to get 2 sine 3 theta and cosine theta plus sine theta times the derivative of this, which will be 6 cosine 3 theta using the chain rule. Now since you need to find the slope when theta is pi over 6, we need to evaluate dy d theta when theta is pi over 6. So that means instead of theta, we got to plug in pi over 6. And when you do that, you get this expression over here. And you know that cosine of pi over 2 is 0. So this whole thing goes to 0. And the sine of pi over 2 is 1. And cosine of pi over 6 is radical 3 over 2. So as a result, you're going to get radical 3. So dy over d theta, when theta is pi over 6, is radical 3. Now dx over d theta will be, again using the product rule, it will be 2 sine 3 theta times the derivative of cosine theta, which is negative sine theta, plus cosine theta times the derivative of this, which will be 6 cosine 3 theta. Again, we have to evaluate dx d theta when theta is pi over 6. So instead of theta, we got to substitute pi over 6. And you get this expression over here after you substitute pi over 6 for theta. And cosine of pi over 2 is 0, so this whole thing goes to 0. And sine of pi over 6 is 1 over 2, so that becomes negative 1 over 2. And sine of pi over 2 is 1. You have 2 in front of it, so you get negative 1. So dx d theta at pi over 6 is negative 1. So therefore, dy over dx is going to be dy d theta, which is radical 3, over dx d theta, which is negative 1. Now that is, of course, that when theta is pi over 6. So the slope will be negative radical 3. This is going to be the slope of the tangent line. Now we got to find x and y. Now when theta equals pi over 6, x is going to be, instead of theta, you're going to substitute pi over 6. So you'll get 2 sine pi over 2 cosine pi over 6. And as a result, you are going to get, this becomes 1. So it's 2 times 1 times radical 3 over 2, which is going to be radical 3. Now y, when theta is pi over 6, is going to be 2 sine 3 theta sine theta. So substituting pi over 6, you get 2 sine pi over 2 times sine of pi over 6, which is 2 times 1 times 1 over 2, which is going to be 1. So x and y becomes radical 3 comma 1 when theta equals pi over 6. Now we have a slope and we have a point. So how do you find the equation of the tangent line? Well, we have to use y minus y1 equals m times x minus x1. So you get y minus 1 equals negative radical 3 times x minus radical 3. So this is the equation of the tangent line to the polar curve when theta is pi over 6. So here we have the polar curve, and this is the equation of the tangent line when theta is pi over 6. Now there is a way to find the slope using a graphing calculator, so I'm going to show you how to do that. Now notice dy over dx was negative radical 3. And our x is 2 sine 3 theta cosine theta. So I'm going to let that equal to r of 1. And our y, which is 2 sine 3 theta sine theta, I'm going to let that equal to r of 2. So now I'm in the polar, and this r1 is my x, and r2 is my y. Now we got to find the derivative. We got to find dy over dx when theta equals pi over 6. So now what I'm going to do is I'm going to press set alpha and y equals and choose fraction number 1. And then what I'm going to do is press math and press number 8 for n derivative. And you're taking the derivative with respect to theta of R2. So we need to choose alpha trace and choose number 2 for R2 because that was our y value. Our y was R2. And then theta is pi over 6. And for the bottom, again, you go to math, choose derivative. Theta, and then now that has to be R1 because our R1 was the x. So alpha trace, choose R1. Again, theta is pi over 6. Press enter. And we get negative 1.73205. Now let's check if that's same thing as negative radical 3. And it is. So this is how you do it with the graphing calculator to find the slope. Again, you got to be careful. The common mistake is students, they get confused what their R1 is and R2 is. Make sure you know which one, because it has to be dy over d theta over dx over d theta.